Okay, so for problem number 60, we have, it says that the time that it takes for an object to drop from the top of cliff A to hit the water to the lake below is twice the time it takes the object to drop from the top of cliff B to reach the lake. And then we're trying to figure out what is the difference. Is cliff A twice the height of cliff B? Is it less than the, or 2 times the height? Is it 4 times the height? We're trying to figure out like the proportionality or the ratio of the 2 cliffs. So again, if I drop a rock from A, it takes twice as long to fall than if I drop the same object from cliff B. So what they want us to kind of figure out is, the question specifically asks us how, if it takes 1.8 seconds for an object to fall from cliff A, what are the heights of A and B? All right. So the first part of the question is like, how high is A compared to cliff B if the time it takes for an object to drop from cliff A takes twice as long as it takes for the same object to drop from cliff B? So they give us very specific. Is it 1/2? Is it 2 times? Is it 4 times? How do you figure that out? All right. Now what this is based on is that some of our displacement equations, we have the time squared. All right? We have the time squared. So what they do is they say, let's give you the exact time it takes for an object to fall from cliff A. If it takes 1.8 seconds for an object to fall from cliff A, how long would it take for that same object to fall from cliff B? So it would take half the amount of time, but now we're asked to find the height. So now that I know the time for cliff A, which is 1.8 seconds, then I can plug it into an equation and find out the height of the cliff by solving for delta y. So we think about the equations that we want to use. There's 2 or 3 that have delta y in them. And so look on page 58 and you tell me which equation we can use. Because we have the time, we have the initial velocity, which is 0, we have acceleration due to gravity, which is g. And so I said that we could use delta y equals v naught t minus 1/2 gt squared. Because the initial velocity is 0, we cancel out the first term. Then we plug in negative 1/2 9.8 times 1.8 squared. If you plug that in your calculator, you'll get that it's 15 meters or 15.876 meters. It's a negative 15.8 because that's the direction that the object falls. But the height of the cliff is 15.876 meters. Now, 1/2 of that time is 0.9 seconds. So I would use the same equation for cliff B, but instead I would put in 0.9 seconds. So I have to square the 0.9. Now 0.9 squared is 0.81. Okay? So when I did this problem earlier today, my students thought it would be exactly 1/2 the height of cliff A. Mathematically though, when I plug in 1/2 times 9.8 times 0.9 squared, we get a completely different number. It's actually almost 1/5. So the actual answer is going to be negative 3.969 meters. The negative sign represents the distance's direction. In other words, the rock was displaced 3.96 meters in the negative direction. So just to kind of summarize what we're doing here, we were told that it takes twice as long for an object to fall from cliff A to cliff B. We were asked to kind of determine what we thought the ratio from cliff A to cliff B height-wise was. Then we were given the time of 1.8 for cliff A, which gives us the time of 0.9 seconds for cliff B, and then we mathematically calculated what the height would be. Cliff A is 15.87 seconds, or 15.876 meters, and cliff B is 3.969 meters. So there's a big difference between the 2 cliffs. So intuitively, we would kind of think, well, it'd be 1/2, but it's not, because the acceleration is meters per second squared. That squaring throws everything off. Does anybody have any questions about that? Does that make sense to you guys?
Not at all.
Okay.